Hello everyone, we are on to Drawing and Word Problems, Chapter 9, Worksheet 7. Here we go. So let's first talk about some vocabulary. The angle of elevation. So this is the angle that's actually on the bottom, which sometimes confuses people because you think elevate is up high. But it's if you were down here staring up, okay, the angle of elevation is here. So it's always ground level going up. And it's a line of sight, which is just a straight line to an object. The angle of depression is actually the same as the angle of elevation. It's just located in a different place. So I'm hoping you're seeing with this Z that's created, the alternate interior angle with that angle of elevation we just talked about. Same thing over here. Now, angle of depression, you're thinking depress, go down. You're absolutely right. But the biggest mistake is that people will put it here, which is incorrect. It's always, again, from that horizon. So it's actually from here down. It's from the horizon looking down, not from wherever you are to, a building or a height or something like that. So the angle of depression and the angle of elevation are congruent, and you want to make sure that you can label both correctly. We make some assumptions in this chapter. We assume that all buildings with ladders on them are nice and straight at a right angle. We assume that people flying kites make a nice, pretty right triangle. You have your height here. We assume that any tree actually is standing perfectly straight up and down, which we know that trees grow all sorts of different ways, but we assume that they're all at right angles. We assume that you're standing at a right angle. And just to point out, if you're ever looking for the height or the altitude of an object, that's here. Okay, horizontal distance, because we like to talk about planes and islands, they go this way. You're going to see a lot of common types of questions here, ladders on buildings, etc. They're very common uses for trig. So let's go over some examples. Your goal is to make these all look like what you've already been doing. You just have to be able to read the word problem and correctly identify the pieces. A 3.4 foot guy wire is attached to a tree 3 feet from the ground. What is the angle that is formed between the wire and the ground to the nearest degree? So again, we have our right triangle here. We know that the guy wire is attached 3 feet from the ground. So it's attached to the tree 3 feet from the ground, not down here, it's on the tree. So that's the height. The guy wire itself is 3.4 feet. And we're looking for the angle that it makes with the ground. So now that we have this picture, it's pretty easy to quickly label opposite and hypotenuse. I know that this is sine, and we perform the inverse of sine when solving for the angle. Now, we always wait to the end to round, and in this case, they want nearest degree, so we're going to say 62 degrees. Number 2, we have a 15-foot ladder leaning against a wall at 52 degrees. Okay, so let's just point out real quick. It's leaning against the wall at 52 degrees. That means the 52 is up here, not down here, because it's leaning against the wall at 52 degrees. The ladder itself is 15 feet, and they want to know how far from the wall is the foot of the ladder. So they're looking for this distance down here. So again, I can now clearly label my opposite and my hypotenuse. So this is sine again. Sine 52 equals x over 15. Cross multiply, use your calculator. We get 11.8201613, but they said to the nearest foot, so that would be 12 feet. Number 3, we have a little boy flying his kite. The string is forming an angle of elevation of 37 degrees. So remember, if you have your right triangle here, the angle of elevation is from the ground going up. So it's your line of sight. So that would be 37 degrees. And from where he stands to directly under the kite is 45 feet. So from where he stands to directly under the kite is 45 feet. How long is the kite string? Well, that would be the hypotenuse in this case. So I have adjacent and hypotenuse, so I know I'm dealing with cosine. Cross multiply, divide by cosine 37 on both sides, and out pops your answer. They wanted it to the nearest foot, so I round to 56 feet. Make sure you're paying attention on where it says to round. An airplane spots floating debris at an angle. I know we got an island here, but let's pretend it's floating debris, okay? It was the easiest picture I could grab from the notes. At an angle of depression of 15 degrees. So remember, if here is my right triangle, my angle of depression comes from the horizon. So it's not here going down, it's here going down. It's alternate interior, boom, boom, with the angle of elevation. You do have to show this, though. If you just put it in for the angle of elevation, it's going to be assumed that you thought it said angle of elevation. So you have to show the angle of depression. It's at an altitude of 3,000. Altitude is the same as height. what is the horizontal distance before they fly over it? So if I'm flying over, and we're pretending this is debris, not an island, that's my horizontal distance, but that's not in my triangle. Luckily, I'm hoping you realize that that distance is the same down here, so I can put my x there. Now I can do O and A, so this is tangent, cross multiply, divide, and we're there. And they want it to the nearest 100 feet, so not hundredth of a foot, nearest 100 feet, so that would be right here. So the 9 is going to round my 1 to 11,200 feet. And the last one is going to get a little bit trickier. So you might be saying, oh, yeah, I got that. Now we're going to do multiple things, so we're going to do more than one thing. A flagpole is at the top of a building, 400 feet from the base of the building. The angle of elevation to the top of the pole is 22. Boom. The angle of elevation from the bottom of the pole here is 20. Determine the length of the flagpole to the nearest foot. So they're asking us for this length in purple. However, this purple length is part of this triangle. And we already said that the ratios only work in right triangles. We don't have a right triangle. However, I do have a right triangle here with the building height as my missing piece. And then I have this triangle with the building with the flagpole as my height that I could find. And I'm hoping that you can see if I take the large length here, the building and the pole, and I subtract just the building, I'll be left with the pole. So that's what I need to do. I need to take these two triangles apart. So I'm going to solve for the pink triangle, which had the angle of elevation of 22. And I'm going to solve for this yellow triangle, which had the angle of elevation of 20. Now, the nice thing is once you solve for these, they're basically the exact same situation, just one's an angle of 20 and one's an angle of 22. Neither of them have a hypotenuse, so this is going to be tangent. Cross multiply, solve. Do not round until the end. Do not right now round this to 162. You're going to end up getting it wrong. Okay. Over here, like I just said, it's the exact same setup, but with 20 instead of 22. Cross multiply, solve. Do not round until the end. So if we go back to that original picture, remember, if I have b minus a, that's going to get me x. So now I'm going to substitute those values that I solved for, and I'll pop 16.0223966. Now I can round. Now I'm at the end. I have the length of the flagpole. So that's about 16 feet. Please, please, please do not round until the end. That is it. Have a great day, and I will see you in class.